My name is Gabriel Hartnell, and I am presenting for video homework 6 for Physics 221. The objective of this video is I can utilize the model of friction to determine the increase in temperature due to friction of an object sliding against another object of the same material. The problem we will be solving is you are trying to start a fire with the old-fashioned way by rubbing a stick into a log. It is 25 degrees Celsius outside and the wood will combust at 200 degrees Celsius. The two pieces of wood each have a kinetic friction coefficient of 0.25. The stick weighs 5 kilograms and is 20 centimeters long. You apply a force of 400 newtons to the stick each time you move it. The specific heat of wood is 1,850 joules per kilogram times degrees Celsius. Calculate the work applied to the stick and the force of friction required to start the fire. First, we want to calculate the work, which is equal to force times delta R. This is the work friction, so we set it equal to 400 newtons times 0.20 meters times the coefficient, frictional coefficient, which is 0.25, and we get a value of 20 joules. Next, we find the change in thermal energy, which is equal to mass times specific heat times delta change in temperature, which is equal to 5 kilograms times 1,850 joules divided by kilograms times degrees Celsius times the difference of 200 minus 25, which equals 175 degrees Celsius, and we get a delta E thermal equals 161. Okay, excuse me. 1618750 joules. We divide this by our work friction value of 20 joules, and we find that it will take 80937.5 times of rubbing the stick into the log to make the wood combust. This concludes video homework 6. Thank you for listening.